Okay, thank you everyone. Let's start. So as you probably might have noticed, I'm not Nick Farr. Nick Farr couldn't be here today, but he's in New York City right now and sends greetings to all of you. As you can see, greetings from New York City. I miss you. Yeah, very artistic picture of him wearing a hoodie actually. Wait. There's even more. So all of you talkers better be aware because he will be watching the streams from Times Square. Okay, for those of you, so let's start. For those of you who don't know what the session is about so-called lightning talks, which are very short talks with a duration of 5 minutes. Every speaker gets 5 minutes, and right afterwards, the next speaker continues. And to make sure that each speaker uses only his 5 minutes, we have this cool device called the Timekeeper, which is this one. Alex built and constructed it. It's a very cool thing. Big applause for him. So for the speaker to notice that his end is coming, we need the audience to tell him so. So how this works is the following. This thing goes up for the first 4 minutes. So everything is safe, it's green, goes up and up and up, 4 minutes passing. And after 4 minutes, so this is a bit faster now than 4 minutes actually. And then when the last minute starts, it turns yellow and fills up the bar with yellow. And then it fills up the bar with red if the last 30 seconds come. And up to this point, we can start with a countdown. Do you know how that works? So we start from 10 and go down. So start from 5. Okay, 5, 4, 3, 2, 1. Yeah, okay. That was okay. I think you can do better because, as you know, Nick is watching and his face would probably look like this now.
It actually starts blinking from 5 seconds on. I think we give it a short retry for the last 5 seconds.
It wasn't that good anyway, so we have to be louder. So 5 seconds looks like this. 5, 4, 3, 2, 1. That was okay, Alex? Yes? Nearly, okay.
I think we can work on this a bit, but we have a lot of time and a lot of chance to do this. So
we have 22 talks. We have lots of time to practice for tomorrow and the day after, where the other lightning talk sessions will be. So how does this work? I would like to tell all the speakers that if you know that your talk is going to be next, please sit up front to be able to get up quickly. And then you exchange the clicker, which is this device that allows you to advance the slides yourself from the speaker before you. And then please talk into the mic. You don't have to turn around to see your slides because there will be a screen down there below the stage where you can see your slides. So I think that's it. Okay, there's a translation available. So most of the talks are going to be in English, and a German translation is available in the translation stream on the streaming page. Or if you are in the hall right now, you can listen to the translation calling DECT 8014. Then have a great session. Let's start with the first talk.
Who is the first speaker?
Yeah, there you are.
So, hello, my name is Leonie Tanzer. I'm a PhD research student at the School of Politics, International Relations and Philosophy in Queens. I'm slightly the fraud here. I'm not a hacker, as you probably can see. I'm a social scientist. And I'd like to talk about my current PhD research and a specific study I'm conducting, which is the secretization of hacking and hacktivism. And the reason for that is because you're actually currently a very interesting research topic, especially in the field I'm working in, which is international security. Because I've already done research on the party and hacktivism and gender stereotypes in the past, my current research project is basically basically focusing on the issue how hacktivism or hacking has become seen as a security threat. And because I'm very unhappy with the current literature in my research field, which is mainly focusing on hacking as a malicious activity, and to a certain extent even arguing hacktivism is a form of cyber terrorism, and also argues that security is like an objective state, either being secure or insecure, I'd like to look into, in my PhD research, if hacking could be seen as a technique, or if it could be articulated in the current research field, hacktivism as a form of political activism, and lastly, if security and that security should be seen as a social construction, which basically goes along with a current theory, which is called securitization theory, which I'm using in my research. And the basic idea of that theory is basically security issues do not necessarily reflect the objective material circumstances of the world. To give a short explanation onto that is basically immigration issues have in the past been seen as a political issue and have been treated as such, but now with what we see with Frontex on the European Union borders is basically that people are treated as a security issue and they're kept from being seeking asylum and refugee. The same I would basically apply to the issue of hacking and hacktivism, how it has become seen as a security threat. And as a researcher, my interest is to understand how and why this securitization process, so how you have become seen as a security threat, has happened, and to identify the effects of it. And so basically the whole thing is what makes a security issue. To investigate this, it's basically the idea to look at a securitization move. So something has been shifted from a political sphere into security sphere, where we all run around like headless chicken and are completely frightened about you guys. There must be an audience, basically the public or the media, which accepts that you have been perceived, or hacktivists or hackers have been perceived as like a security issue. And there needs to be a policy, which we see with the current legislation processes. My PhD research is split up into 3 parts, whereby there are multiple levels I'm focusing on, and also the aspects of resistance. So basically how people who would consider themselves hackers or hacktivists disagree with the current state of art. And therefore I'm basically talking here today to announce my second study, whereby I would be interested to talk with people who are being securitized. So the securitizing actors are normally policy level, or in this case of hacking and hacktivism, the industries, McAfee, etc., where they are talking, oh, we need to deal something, and the audience accepts that. So the second study is basically looking at how hackers and hacktivists deal with that current climate. And therefore I would like to basically make you aware of my call for participants. So there is a link which I will be sending around through Twitter as well, where you can find information on what I'm doing, how I'm doing that. I have ethical consent for that, and what I'm basically investigating. And basically the idea of that short talk should be basically to make you aware of that, to hopefully get some of you participate in an interview with me, just spread the news and basically help science. And please feel free to contact me, and thank you very much.
Thank you. Thank you very much. Now for the next talk. You may start.
Okay. Hello. I'm going to talk about the smart card reader. I'm Pepijn de Vos, freelance developer maker. I'll post code and slides and everything on the on the website later. So I wrote this talk and then wrote on Twitter that I was going to give it, and then a security researcher contacted me and say, "Hey, we did the research a year ago. And we've actually found some security issues with the thing." So then I updated my talk to include what they found as well. Actually, one thing I want to point out is that it's really great to talk about things you don't understand, because I don't understand anything about smart card readers really. But you get all sorts of interesting contact with people and learn a lot. So the talk is also there. This is me and them compared to level of sophistication. They actually found some issues and I was just messing around. I'm going to talk about the Identifier 2, which is the bank reader from ABN AMRO, Dutch Bank. You insert your card, you log in, enter a PIN, pay. You can do the same with the USB cable, which is in theory more secure, but now you're having two black boxes in C exchanging binary data, which is kind of, I don't know, interesting. So the first thing I tried was just like log in over and over and over and over again. And you see this sort of like this kind of linear thing, which looked kind of bad to me. But the security researchers told me like it's this protocol, and it's like the transaction counter that's incrementing, and it's the most significant bits. So it's probably nothing to see here. Then I looked at the USB protocol because I was tired of typing all the 100 responses and codes. We like looked at Wireshark. You can see here there's like all the steps that it goes through and inserts the card. It shows your card number in decimal and hexadecimal, which is kind of a weird representation, but whatever. And there's this like signed data that's getting signed by your card, and then some display text that's going to display on the screen. You press OK, and then it confirms the transaction. So I did something like replay this by USB and changed a few bits of text, which you can see here. This is not this is like what the researchers found. They used like a Lego robot and machine learning and all kinds of awesome things. And they found that it's possible to get the signature and confirm the transaction before the user presses OK. So you could like show some things on the screen and then just go do the transaction without their consent, which is kind of bad. They told the bank and they released a firmware upgrade. So if you have this ABN AMRO bank, you can tell if you have this vulnerability or not by holding 5, inserting your card, and if you see this 1.2 version, you are vulnerable, and if you see 1.5 or higher, you're fine. Yeah, and I think that's it. Thank you.
Thank you. Thank you very much. Now for the next talk. Go on.
Can I start? Yeah. So I recently got interested in the genetics of Indo-European languages, such as German, Latin, Persian, etc. Linguists say that all these share a common ancestor they call Proto-Indo-European, or PIE. It's reconstructed by analyzing similarities between these languages, unlikely to arise from mere accident or borrowing between neighbor cultures. Similarities that affect the core of a language, such as its most basic vocabulary for body parts or its basic grammatical structure. Let's take two languages A and B that in their core share the same words for the same things. Here it's reasonable to assume that these derive from the same proto-words. And if A and B share a lot of such similarities, that they derive from the same proto-language. Now in practice, such similarities are often more or less strong. The weaker such similarities, the more question marks we have to put into our proto-word reconstructions. And if there's lots of such question marks, these proto-word reconstructions become doubtful, or even the existence of a common proto-language. Luckily, we usually have much larger data sets to track similarities, reducing the weight of individual deviations. Still, we somehow have to explain these deviations. This is usually done by positing certain regular language changes, such as all A sounds becoming O sounds in some language, or all B sounds becoming P sounds. These changes, however, need to be regular. They must affect all words borrowed from the proto-language or retained from the proto-language. And if we find, for example, some word from the proto-language that retains its B sound, then our rule is false, and we have to refine it to, for example, affect only B sounds before A sounds. Now, from such reconstructive work, we may derive entire chronologies of steps by which one language, in a certain order, changed into another language. My own current interest in such chronologies of language change affects PIE grammar particles, such as the different endings nouns may take with different grammatical cases, gender or number, that is the particles of the nominal inflection or declension. On this topic, I found no online resources that satisfied me. This Wikipedia table, for example, is as hard to grasp as it is imprecise in regards to the scientific literature. So I decided I wanted to build my own online resources on that topic, the evolution of PIE noun endings. So I got me some of the literature and I tried to draw from that data about the development of noun endings, put that into some XML format that I could then process with some XSLT code into fancy annotated HTML tables. Here's a simplified example of what my XML format currently looks like. There are sets of grammar table elements, each of which fits a specific stage in language development. Inside these grammar table elements, there's elements for different grammatical categories, such as case or gender, which are to be made into table header cells later on. Intersections of these categories are mapped by paradigm elements to specific noun endings and also to footnotes that describe where in the scientific literature this ending is attested for this language development stage. My XSLT code processes from that something like this. This table in the middle, the colorful table cells are noun endings mapped to specific grammatical cases. If you click on any of these noun endings, you jump to a footnote that tells you where in the literature it is attested or from which earlier language development stage and thereby linked grammar table it is retained into the current one. Now, the colors, each color fits a specific noun ending form, which is mostly to highlight noun ending forms that occur more than once. So for an individual table, that may be a bit of a visual overkill, but it makes sense once you remember it's all about tracking the changing distribution of these endings throughout the entire chronology of language change, so that one could, for example, jump step by step from an earlier stage to the next one, and so on, and so on, and so on, and thereby follow the distribution of these endings, like in frames of an animation. So if you're interested in these topics, up there is the current state of my beginning work on that on GitHub. You may also contact me under these addresses. I'd be especially happy to hear from people who have ideas on how to improve such tables, or who are actually, in contrast to me, a bit more knowledgeable about linguistics, because I'm just an amateur and may have overseen obvious mistakes or obvious prior art trying to solve the same problems. So, hi Nick Farr, we all miss you very much. Thank you.
Very nice, all keeping in time, very good. So the next talk.
Hi. I drew this picture of the Congress. Some of you, how does this work? Okay. Oh. Okay. Okay. Yeah, some of you might have seen or even bought it because I printed them as posters. And I wanted to tell you how I made them. First, I sketched it on paper. And when I decided that I wanted to change things, I, to save time, just made notes on what to digitally alter later, like this. Then I traced the entire thing until I had these outlines, which I then filled with colors and even more colors, even more colors. Few things that I want to point out. The choice of perspective in this is on purpose, because with this kind of picture, you don't want a specific focus on anything. The most common kind of perspective these days is the one using a vanishing point, where objects in the front appear larger than the ones in the back, which draws attention to the object in the front. So you don't want that. Instead, I use an isometric perspective, where all the measurements stay the same, and where an object is located is only indicated by its placement on the grid. And some other things I pay attention to, like you can see that some of my characters basically all look the same. They're all bold and wear the same sweater, just in different colors. That leads to an unfortunate effect. Featureless characters are usually read as male. So when you got these stick figures and you want to make sure that people know there are other genders, you got to make that clear. In visual art, what's not visible is not existing. Same goes for things like race and disability. But you got to be careful there, because when you're illustrating and you have like 5 people and then they wind up looking like that, you got these token minorities that are themselves offensive and also incredibly lame. And I try to avoid that. And another thing about visibility is that it doesn't have to be a really realistic percentage. It just has to be visible. So this is the example of visibility. In this case, last time I counted, I might have miscounted. I drew 245 hackers, and only 6 of them are visible disabled, which is less than a German general population. So it's not realistic in that sense. But I guess my point is, just if you want something included, you have to show it in visual art. That's the point. And you can find both me and the poster at the No Drama Assembly as well. And yeah, Nick, if you send me your home address, I'll send you one. Thank you.
Thank you. Okay, the next talk is going to start soon. Yeah, should work now.
Okay. Hi, I'm Swally. I code demos. I want to explain to you a simple effect called the plasma effect that's implemented by using Zinus tables and pseudocolor palettes. An attention from me, it's just one way. There's not the effect, it's a family of effects, and I'm showing you just one way I did it. So, some random notes. Last year I did a talk on why I'm demo coding, now I'm going to do how. This is an 8-bit implementation, so because it was on an Atari 2600 VCS. What's the fastest way to do calculation? It's to use lookup tables. So we're going to use this one for the sine wave function and for optimizing the pseudocolor palette that's available. This is just an example on what a pseudocolor palette would look like if you just use grayscales. This is not what I have in the hardware. In the hardware, I have this one. When I would be using NTSC, I'm using PAL. For technical reasons, this color palette got stripped down, but I was lucky because the Zircam guys, they are screwed. So I want to optimize this one. For this one, I need a reference. I think the color or the ordering of the colors from the NTSC looks quite nice, so I try to replicate this one. I'm doing this by reordering just the colors. This looks like this. And filling in the grayscales with already used colors, so I'm just throwing in some frog DNA. So short recap, something is still missing. This is what I started with, and this is what where I'm now. But if you take a look at the bottom, this flashing still looks something, it could be improved. So what, we only have 128 colors there right now. So if we take the columns and all squash them together, so it gets bright up to the middle and then gets dark to the end, then it would look something like this. And I think this looks quite nice to use. And this is what the original color values are. So this is my Zinus table. I'm using only half of the available values from 00 to 7F. Because I want to add Zinus values, and so I've got the option, I don't have to divide it afterwards by 2. So this is what the Zinus looks like, the original one. I'm using 2 to add them together. One has a higher frequency and the other one has a lower amplitude. And if I add them together, they look something like this. Also looks quite nice. So let's turn it around by 90 degrees. Then it looks like something like this. And now for each line, we don't plot the color on the X position, or we don't plot a dot on the X position, but we're going to use the lookup table I introduced for the colors. And then it looks something like this. And I think this looks quite nice. This is what would look like with the example color table, just using the grayscale. Okay, but I think this one is better. And this is what the original implementation on the Atari VCS looked like. I think it really did something. So now let's go to a 2D implementation. These are also called the raster bars because each raster line, the color changes. let's go 2D. This is what I did. That's an example on how it could look like if you just add them in a two-dimensional array. But this looks rather like a moving plane. So to get it more effect-like, I'm going to divide this, make it more blocky. Each color block will be 16 by 16 pixels, and the whole block will be colored by the color that would be used by the top left color of that area. And then it looks something like this. And from here, I have to take a shortcut. I cannot show you the whole implementation on how I did the 2D because I used different algorithm for this one or different parameters, sine waves. But the original implementation looks something like this. Also, I think, quite nice effect. And to my conclusion, doing a demo effect is easier than you might think. Take a look at other stuff, port it to other platforms. The internet is your friend. There's a lot of stuff around there. And fool around, just test it, and you will be surprised how easy it is and how easy it is to make something that looks nice. And even if it's just for some title screen, some logo of your software, your application you're going to hack up. Try it, it's fun. And if you want to see the full demo, you can visit me at the Leitstelle at the Milliways. It's in between the Türtris and the TARDIS. And if you want to start coding on this very ancient hardware, I'm doing a self-organized workshop on day 3. So it's tomorrow at 2100 in Hall 13. So thank you.
Just a short announcement. So if you are interested in the slides, most of the talkers have uploaded their slides to the wiki. So look at the wiki page of the Lightning Talks and you will find most of the talks. Otherwise, you can contact the speakers because they gave their email addresses. If you are really interested in what has been shown there, just ask them. Go on.
Hello, my name is Luther and I'm going to show you a project of ours, which is called YASP. Ours is me and Robert Fischer, who looks like that on the internet, but cannot be here today. So we both went to the same school in Vienna, HTL Sperrengasse, and there they teach the students in the first year the assembly language just to grasp the basics of computing a little bit better. So for that, they used this board, which is basically developed at the school and was developed like 10 years ago, is hand-soldered and works generally really nice, but sometimes it breaks down and just eats up the time of the lessons. So we wanted to fix that. It's called USB Master, by the way. So we did that. We moved the whole development process into the browser and basically wrote an emulator and assembler and a nice IDE for the whole thing. So you can see there just an editor and a list of labels to jump to, and of course a run button. And yeah, some things you can do with it is, for example, just blinking an LED. So you see the assembly dialect is really easy, so the students can easily understand what is going on and don't have to memorize complex commands and such. So basically here, you see just an LED which is blinking. So you loop and delay. So you loop, turn the LED off, turn the LED on, and repeat that. What we also can do here is interrupts. So you've got these two buttons at the bottom, the gray and the red one. And basically what happens here is we've got a main program with just does nothing, and an interrupt service routine which gets called if you press the button. So if you press the button, the LED just turns on. And another interesting thing we can do is pulse width modulation. So in real life, if you turn an LED on and off a bunch of times, basically the LED gets a little bit dimmer, dimmed, and we have simulated that in our implementation. So if you do the exact same thing in our emulator, the LED will be a little bit less light depending on how much of the time it is on and how much of the time is it off. So you can see that here. And of course, if you write programs, you also need to debug them. So we wrote the debugger for the thing, which you can see here. Normally the two parts which are the two parts are next to each other, but I ran out of space on the slide, so they're under each other right now. And the whole thing, after we finished it, we put it on GitHub and since it's a school project, there's lots and lots of documentation, which you can find here and on the website. And maybe you want to take a look at it, or maybe even contribute something, give us comments, what you like, what you would like to see in it. And yeah, basically that's it. The website is here. If you want to contact me right now, they're stacked. So if you want to speak to me here, you can just call me if you're a teacher and you want to use that, and there's some feature you're missing or you want to really see in there, just give me a call. And if not, any questions?
Yeah, we still have time for questions, so yeah.
Yes. Well, it's
what architecture is it based on? Yeah.
So basically, the dialect is the same which the teacher came up with like 10 years ago. So I don't really know. We just wanted to replicate what was on the hardware, and it's just, I don't think it is based on anything specific. Just to be simple. Anything else? Well then, thank you.
Yeah, thank you. And the next speaker, please.
Hallo, ich bin Thorsten und engagiere mich für die Zeit nochmal. Und engagiere mich für Was tun, eine Berliner Lokalgruppe gegen Überwachung. Und ich möchte darüber reden, warum es wichtig ist, sich jetzt politisch an der politischen Willensbildung gegen Überwachung zu beteiligen und was man dagegen alles tun kann. Seit 1,5 Jahren wissen wir von der Totalüberwachung. Totalüberwachung ist der Angriff auf die Volkssouveränität. Erinnert euch, Demokratie ist der Mechanismus, mit dem der Volkswille durchgesetzt werden soll. Mit der Totalüberwachung und dem Wissen, das Volk wählt Vertreter, denen es vertraut, denen es vertrauen muss, und beauftragt sie, in ihrem Namen zu handeln. Und mit der Totalüberwachung, mit dem Wissen um die Geheimnisse und über die Schwachstellen und Schwächen der Politiker und der Amtsträger gelingt es dann kleinen Gruppen oder fremden Mächten, diese Volksvertreter dem Volk auszuspannen und für die eigenen Interesse einzuspannen. Dass sie nicht mehr dem Volk dienen, sondern den fremden Mächten. So, das ist die Situation, die wir kennen, aber wir sind nicht ganz wehrlos. Unsere Verfassung kennt ja einige Instanzen, die genauso einen Angriff abwehren sollen, zum Beispiel unsere Geheimdienste, zum Beispiel unsere Regierung, zum Beispiel die Parlamente, unser Parlament. Was sich da getan hat, wenn wir das anschauen, ist natürlich erschreckend. Unsere Geheimdienste haben uns eher verraten, statt dass sie uns schützen. Sie haben den Five Eyes zugespielt, anstatt dass sie den Datenabfluss sofort gestoppt haben, seitdem sie es wussten. Sie wussten es schon vor Snowden. Sie haben schon mit X-Keyscore gearbeitet und wussten also Bescheid. Genauso bei unserer Regierung, die verhüllt sich, die fällt in Schweigen und Passivität. Es wurde auf öffentlichen Druck mal eine Ermittlung aufgenommen, aber inzwischen auch wieder fallen gelassen. Und auch unser Parlament hat wohl einen NSA-Untersuchungsausschuss eingerichtet, aber auch das ist eine Lachnummer geworden. Also man hat fast den Eindruck, als ob unsere Instanzen, die genauso einen Angriff auf die Demokratie vereiteln sollen, als ob die schon alle korrumpiert sind. Aber es gibt noch eine letzte Instanz, die dagegen arbeiten sollte, und das ist das Volk. Das sind wir alle. Wir sollten uns eigentlich organisieren, und genau in diesem Notfall, den wir jetzt haben, haben wir unsere Freiheitsrechte, von denen wir jetzt Gebrauch machen sollten, um unseren Willen zu artikulieren, um uns zu organisieren, um das durchzusetzen, dass Maßnahmen gegen Totalüberwachung getroffen werden. Aber auch hier gibt es eine eigenartige Passivität. Es gibt seit 1,5 Jahren kaum Regungen im Volk, die sich dagegen organisieren. Da ist also Handlungsbedarf, aber hier kann ich es nicht auf irgendeinen fremden Funktionsträger die Verantwortung abschieben. Hier muss ich mich an die eigene Nase fassen und sagen, was habe ich eigentlich gemacht in diesen 1,5 Jahren. Ein Jahr habe ich meinen Hintern nicht hochgekriegt, aber seit einer kurzer Zeit bin ich jetzt dabei, mich zu engagieren, und habe mal die überwachungskritische Szene angeschaut, die es in Deutschland gibt. Die ist sehr überschaubar, und es gibt so 2 große Lager. Die einen sagen, wir müssen die Lösung in der Technik suchen, und die anderen sagen, die Lösung liegt in der Politik. Die 2 Lager sind eigentlich überflüssig. Wenn man sich es genau anschaut, es gibt diese Technikbegeisterten, die haben schon sehr viele interessante Lösungen mit Verschlüsselung entwickelt. Also technische Lösungen sind tatsächlich in Greifweite. Aber sie haben keine Verbreitung erreicht. Und insbesondere unsere Amtsträger, unsere Abgeordneten und Geheimnisträger nutzen die noch bei weitem nicht. Und das andere Lager, also diese Frage, dass diese Lösungen Verbreitung finden, das ist natürlich keine technische Frage mehr, das ist die politische Frage, die dahinter steckt. Und da wissen wir, die Politik, die steckt in dieser Frage noch in den Anfängen, das heißt, da ist noch gar nichts entwickelt worden, obwohl genau da die Forderung anzusetzen wäre, dass diese technischen Lösungen, die bereits existieren oder die in Kürze entwickelt werden können, dass die zur Pflicht erhoben werden, gesetzlich. Also die Frage dieser Lager ist nicht Technik oder Politik, sondern Technik und Politik. Und wir wissen, Technik ist machbar und Politik, da ist es noch in den Anfängen. Und deswegen heißt das Gebot der Stunde für uns alle, wir müssen uns politisch engagieren. Und dafür ist es wichtig, dass wir uns vernetzen. Wir müssen Ortsgruppen bilden und so eine Ortsgruppe ist zum Beispiel Was tun, aber es gibt auch noch Stop Watching Us und viele andere. Was tun, wir haben einen Stand in der Noisy Square, da haben wir eine Deutschlandkarte aufgestellt, in der wir die Ortsgruppen eingetragen haben. Wenn da eine Ortsgruppe noch fehlt in eurer Region, wo ihr euch engagieren wollt, dann kommt trotzdem zu uns und dann schauen wir, dass wir euch vernetzen können und dass dann neue Ortsgruppen entstehen. Dass über die Ortsgruppen mobilisiert werden kann, Ortsgruppen können der Anlaufpunkt sein für Interessenten, die sich gegen Überwachung engagieren wollen. Das muss ausgebaut werden. Und die Arbeit kann einfach anfangen mit Infoständen, und man kann zu bundesweiten Demonstrationen mobilisieren, man kann sich an kreativen Aktionsprotesten beteiligen. Das sind alles die Formen, die man machen kann. Also kommt zu uns und organisiert euch und beteiligt euch an der Entstehung von Ortsgruppen. Ein letztes Ding noch, Überwachung ist ein sehr abstraktes Thema. Man kann es schön visualisieren durch den Camhead, eine Pappkamera, die man sich leicht bauen kann, echtes Low-Tech. Damit kann man Bildern liefern, die Menschen ansprechen und die Medien ansprechen und damit den Protest visualisieren. Und wer Lust hat, der kommt zu uns. Wir haben viel Material mitgebracht, bastelt sich seine eigene Kamera und macht an einer kleinen Demonstration am Ende des Kongresses mit uns mit und an Videoaufnahmen. Vielen Dank.
Okay. We just heard about the political angle, so here's the technical one. I'm organizing the We Fix the Network shop. As you just heard, we should all be aware that technical solutions are urgently needed. I'm not quite agreeing that, oh yeah, they're just around the corner, we just have to encrypt. The flying pig news of today might educate some more people on that. Currently, the internet does not serve civil liberal society. We want to build one that does not serve mass surveillance and war, but instead that can be used for private communication, for education, and for responsible commerce. So the workshop today, where various projects present their angles, their ideas for how to improve or re-architect the internet, is happening all day in Hall B. We're currently on lunch break, so you don't have to leave the lightning talks. You can meet hackers from CDGNS, GNU-net, You Broke the Internet Last Year, Tor, Net2O, I2P, Ethereum, Leap, Tails, Fenrir, and more. And you're very welcome to join us. Also, in terms of you wanting to become active, we are all looking for more people to help out. I'm starting a new research team at INRIA in France. That's there on the map in Rennes, so far away. You know, we're somewhere here, right? This is a new lab where we're going to develop free software solutions, so all free software, to improve network security. In the context of the GNU-net project and the Thaler project, we are looking for people to join us. So if you are currently lacking, having the excuse of not being paid to develop free software to improve the world, well, no more. If you have ethics, a master's or doctoral degree, systems programming skills, user interface development skills, or something else that you think you can bring to the table, talk to me. We have lots of open positions. And I would love to have a strong team to fix the internet. Thank you.
You still have a lot of time, so maybe we can do a quick Q&A. Is there a question? Yeah, over there.
Is the stack only focused on security and privacy, or are there other things I want to fix about the net? Security and privacy are the main things, but of course, by decentralizing, we are also trying to take care of control issues that we have right now, where you have censorship. I would include that into security. So it's a question of what you mean by security and privacy. If you interpret these terms broadly, I think that is really our focus. Performance is not the focus. for example. But usability, for example, would be a focus because we're only going to get good security if you can have lots of users, right? Or you could say it's an availability goal because if you can't use it, it's not available to you, right? So in that sense, interpret these terms broadly, and I think this is the scope. This is the first one. Oh.
There's a question over there.
Yeah. The question is this sponsored or also sponsored by the French military? Okay. I was told that the security center is going to be sponsored by 20 positions by the region of Bretagne and by 1.5 positions by the French military. So they are somewhere in there. Then I immediately asked, so what do they want? And they said they want better free software to secure their systems. So they did not say, we want you to break into other people's systems or do mass surveillance. And then I said, well, okay, that could be fine. What do you expect from me to do? And they say, just to build this GNU-net thing and build a better network. And that's fine with me, as long as those are the requirements. So yes, there is government sponsorship involved. It's not even dominant at this point. And I do not know if I'm going to get any of these 1.5 positions from the French military. But the French military is somewhere in there.
Okay, thank you very much. Next speaker, please.
Hi. I want to talk to you about Bolt's open library for technical specifications. And where's this thing?
Did the previous talker take the clicker with him?
No.
Is the previous talker still here? Is my clicker gone now? Thanks.
So
reset the time, please.
Yeah. So Bolt's an open library for technical specifications, and it starts with digital fabrication. 3D printers, CNC, mills, and laser cutters are super cool tools because you can basically build parts in almost arbitrarily shapes, which allow you to build basically anything. Computer-aided design is a central ingredient to that process because you always start with a digital model of your design. But even though you can build arbitrarily shaped parts using standard parts like nuts, bolts, bearings, or profiles, it's still a good idea because it allows you to make better, cheaper, and simpler designs. And there's the problem. There's excellent free and open source CAD software available, but it doesn't come with a standard parts library where you can just easily insert standard parts like nuts, bolts, and other stuff. Commercial software usually has this available. So Bolts is an effort to try to fill this gap. It's a modular system to develop part libraries. And it tries to target not only a single, but many different CAD systems by leveraging parametric capabilities of the CAD systems to create from one parametric geometry that is specific to the CAD system and a big table with the dimensions and parameters for all the different sizes and variations of a part to create from this the standard parts library. It is based on a human-readable format for marking up these tables with parameters. It does automatic consistency checks to ensure that the data is somehow usable. We automatically track the license of geometries and data, which allows us to build subsets of part libraries that are compatible with certain licenses. We support translations of the parts. Everything is managed in Git, which makes it easy to contribute. And currently, 2 CAD systems are supported: OpenSCAD and FreeCAD. OpenSCAD is a scripting language for 3D modeling, so you basically program your shapes, which is very cool and powerful when you come from a programming background. There will be a lightning talk tomorrow, I think, about OpenSCAD, so if you're interested, look at that. It looks like this. It's very simple to use bolts with the OpenSCAD. You just include the library and then call a module, which is kind of like a function that tells the system to insert in this case a hexagon bolt according to DIN 931, and there it is. If you cannot remember all these names, that's not a problem. Many of the parts you can also refer to by more easily rememberable names, like here the T-slot extrusion. FreeCAD is closer to the classical CAD software, where like AutoCAD or CATIA, and there bolts is included in the GUI, so you can select the part you want, enter the parameters, and click a button, and there it is. The bolts website also has a nice list of all the parts with drawings and all the tables and other information. So if this sounds interesting to you, I'm happy to talk about it, to discuss it. So just drop me an email or contact me anyway. I'm around. Check out the website, try it, and tell us what works and what doesn't work. You can also happily invite it to help with improving documentation or translation of the parts. So at the moment, the German translation is quite in good shape, but other languages can always profit from more people helping out, or by adding more parts to it to make it more useful, or by helping with porting that to other CAD systems, which should be easily possible. So thank you.
Thank you.
Hi, I'm Marcus, and I'm here to talk about information and interaction being combined. So let's start with getting interactive a little bit. I would like you to guess how much Germans spend on newspapers every single month. Any idea? Just guess. Give me a number. Okay, let me tell you, it's €500 million every month. Now let's spotlight the information part a little bit more. Two questions here. How do we deal with information, and what does it turn us into? Well, when it comes to newspapers or television, we usually consume the information, and we are doing it most of the times on our own. Now, our reaction to consuming the information can be manifold, but just 3 examples. We could get angry about the information, we could get apathetical, we could get depressed, but again, we do that when we are on our own, so alone. Now, if you look up the definition of idiot in its primordial sense, it comes actually pretty close to our behavior when we consume and deal with information in the traditional way. How come? Well, I think one reason is that if you consume information, it's typically a one-way road. So the information channel communicate to us, not with us, okay? So to some extent, it's dead end. The whole setup of these information channels do not allow us to ask questions, to comment the information, to discuss it with other people being interested in the topic, or, which I think is also important, to link the information ourselves to other information that is relevant to the topic in a convenient and timely manner. So isn't it nice then that we nowadays have other opportunities and new channels available? Well, to some extent it is, but as you might all know, Googling things has its own constraints. Some of the more simple constraints are it's time consuming to do the research ourselves, and it costs a lot of energy. So for many people being in day-to-day life, it's just not affordable. There are other programs you could use. I just highlighted 2 of them here, Facebook, Wikipedia, which have really interesting features to deal with information. But at the end of the day, they do not really deliver what we need. So, in my opinion, it's important to get information, discussion, and action aligned in one single channel. I would like to take the best out of Wikipedia, Facebook, supplement it with some additional and important features, and create a new information channel. So my intention being here is to meet with talented and ambitious programmers to get this thing rolling. And I would be interested in meeting with you outside after my talk. I will also be there at 3 o'clock at the elevator if you turn to the right when you exit this room. And let's just discuss how we can get this thing rolling, okay? Thank you very much.
You still have some time. Would you like some questions?
Oh yeah,
yeah.
So I'm happy to.
Anyone has a question? I don't see any questions. Yeah. Okay, so then we'll just continue with the next talk. Thank you very much.
Hello, my name is Felix, and I have just one slide. On the right side is some kind of roadmap. I want to get to that in a minute. And on the left side, you see a screenshot of the realitybuilder.com website, which originally I wanted to show you, but I cannot do it because I can only show slides. So what you see is an image of a construction site. And on top of that image, you see some kind of like augmented reality overlay. And you can move around this virtual block with the cursor keys there. And then you click on Make Real, and it actually gets built, for example, out of stone. I mean, this is, of course, pre-recorded. This is not live. Well, the core idea of this whole thing is that with the click of a mouse button, you can change the physical world. And another important aspect is that many people at the same time can build a construction collaboratively, and the outcome is totally unclear. I think it's it's best not to think too much about if it makes sense or not. It's just an experiment. And not for the roadmap. There are 3 stages. There's something we can try today. Then the next step would be to do this on the Canary Islands in Big. I've lived there for several months this year and last year, and there's nice locations. One of them is the CHT hack base in Lanzarote, or in Las Palmas. We can do it where there's always mild weather. Make it with big blocks, and then in the future, well, I'm in a team with people, and we want to build something big in Berlin. But now let's get to what we want to do today. And there's a session in the hardware hacking area today in Hall 3 from 3 to 6. And I don't know, maybe longer and maybe also tomorrow, depends how fast we can set up all this. And the idea is to make a low-tech solution. We will just stream via Twitch and the channel RB31C3 and put some webcams, put a webcam and film this these Lego bricks. I have 564 of these white bricks, and then people can send coordinates, and we will build in the coordinates. This will take some time to set up, and I would be glad if some people could join that know a bit about Twitch, because I'm all new to Twitch, also, the challenge is to get an audience so that people actually play this. So please join offline at the hardware hacking area or online at the channel. Okay, I think, yeah, if you want to reach me, I put my, my Twitter handle there and my telephone number. I also have a GSM number here, which is 6052. Yeah, again, don't think too much if they make sense or not. It's really just in a test what happens. Okay, thank you.
So we would have time for one question. Does anyone have a question on this project? Yes, here.
Huh? On my head? It's a panoramic camera. I just was thinking I'm going to film my own talk.
Okay, we'll have to talk about that probably.
No, it's just for first. It's not. I'm not going to put this online.
Thanks. Any other questions? Yeah.
The pyramid. Those are just the Lego bricks. I have actually more, but they're nicely arranged like this, I think.
It's easier to carry around.
Yeah.
Okay, thank you very much. Now we have a 15-minute break. So if you want to leave for a short time period, then you are free to do so. And we'll see each other again at 2 o'clock. Okay, please sit down. We can start. So we are doing the next part of the first lightning talk session now. And would the next speaker please come up to the stage? All right. The clicker should be there. Yeah, it is. Go ahead.
Okay. Cool. Which one should I press?
Right is the next slide, left is the previous slide.
Okay, yeah. Hi, I'm Dan from CCC Munich. And I've been in the IPv6 business for a few years now. And I can tell you that we need more and better IPv6 software. We need more alternatives to choose from, ideally open source, and we need much better quality in this software. So I accepted the challenge and designed an IPv6 router advertisement daemon to get used to writing IPv6 software. I'm a network guy, so I love CLIs. Therefore, I decided to write two programs, one daemon for the actual work and one CLI tool for controlling the daemon and configuring the system. So what about the challenges of a modern router advertisement daemon? This is an interface on a Linux box. All the things in red are subject to change during runtime. And a route advertisement daemon should be able to handle these changes without breaking any client's connectivity. So I ended up with a very dynamic software design. I have a Unix socket for the CLI, a netlink socket to listen to the kernel for interface configuration changes, and I have a few raw sockets for sending and receiving ICMP6 packets and raw data. I maintain state and configuration data using an in-memory database, and I use threads for the actual work. Today, RA tools come with a couple of ICMP6 options. It also features a super easy to use module architecture that allows the implementation of new options in under an hour, including the CLI definition, given that you have a bit of basic C understandings. This is a syntax example demonstrating how to create a new route advertisement on VLAN 3000 on Ethernet interface 2. And this is taken from the currently running Congress Network's Net64 configuration. So this software is currently running and serving the Net64 network. This is how monitoring and statistics look like. I give you a couple of seconds to see it. So I've been working on this software for a year now, and my conclusion is that there are a lot of misunderstandings on how to implement the RFCs. And maybe I got it wrong, or maybe other vendors got it wrong, or maybe people programming just don't care enough about the RFC documents. But we have some issues in in other software, and probably also in mine, which breaks IPv6 connectivity. So this means if we have bad software quality, we will lose our connectivity. And once IPv4 is gone, this is not an option, that we have no connectivity. So here are my conclusions. And I prepared a little checklist that may help you to detect non-optimal implementations. Many implementations cannot advertise admin-defined source link layer addresses. Some do not support the ICMP6 RDNS option, which means that you have no DNS unless you use DHCP v6. And without DNS, the internet is broken. Few of them are not state keeping, and some of them never heard of de-advertising. So as soon as the software stops working for some reason, maybe due to a configuration change, it does not de-advertise the data or the prefixes in the network, so clients lose connectivity, which I think is not an option. Yeah. Thanks for listening, and use more of the Net64. Share your experiences. It's C3Knock on the Twitters, or you can use my handle if you want to contact me personally. use more bandwidth and use more Net64. Thank you.
Thank you. Next speaker, please. Bitcoin mining. Anyone wants to talk about that? Oh, there, okay. The clicker should be on the, yeah, all right, go ahead.
Okay. I'm going to briefly introduce one new service for Bitcoin mining pools. And the service is, it's Virgin Coins. So I'm going to explain what Virgin Coins are, why would anyone want them, and how did we actually make it happen. Okay. So what are Virgin Coins? It's basically never spent Bitcoin. It's Bitcoin with no history whatsoever. You pay a fee, and you also pay the amount of Virgin coin you want, and give us your address. And we will just make sure that the Bitcoin is mined directly to your wallet. It's very easy. But why would anybody actually want Virgin coins? Well, you've probably noticed that Bitcoin doesn't have exactly the best reputation. And so there are many people that would like to use Bitcoin, but are actually afraid of the coins that have some not so great history. So for that, the coins without any history are probably ideal. So you would avoid suspicious sources. Also, you don't want to bother mining yourself, as most people probably don't want to mine nowadays. And the other thing is that it will definitely have collectible value. Maybe not now, when still new coins are being mined, but in the future, when the mining stops, you won't get any new coins anymore. And the extra feature is that when you request a whole block, at the moment it's 25 Bitcoin, you get to choose your message written in the blockchain and spread all over. So now I very briefly describe some technical overview how we actually build it. The service is another service on top of mining pool operations. It's written in Python. It heavily uses the asynchronous server-client architecture and relies on Python twisted. Here, the server creates custom Coinbase or block template with the new Virgin coin addresses and pushes the Coinbase to the miners. And the miners do what they always do, they mine, but they mine for this new Coinbase. And finally, we also need to verify the payments for the service and the success of the mining, that the coins, the Virgin addresses are already in the blockchain. And for that, we use the normal Bitcoin API. And yeah, we also use the BIP32 hierarchical deterministic wallets for generating the addresses the customers can pay us. So we will soon going to actually deploy it and test it and find out how much do you want it. Thank you.
Thank you very much.
Can we please remind all speakers to be ready here at the podium, and please return the clicker? Hello, hello, hello.
It's here.
Okay. Okay,
Hello.
Please, the next speakers, please come in front of the podium before your talk starts.
Hello. I want to tell you a bit about the fuzzing project. I'm using Linux and free software, and I think many of you do too. And I like my system to be secure and stable. And of course, you know, Linux is always secure and all free software projects are always stable because everyone can find bugs and fix them. Unfortunately, at some point I learned that's not always true, so I tried to do something about it. I don't know, I mean, many of you probably use a command line and may expect that a tool like less or strings or file is secure and you can use it on untrusted input. But that's not the case. All of these tools had bugs recently that are probably security bugs, and you can probably be exploited by them. So what's fuzzing? Fuzzing is very simple. You just take some input for some software, and then you add random errors to it. So like, let's say you take a image file, a JPEG, just flip some bits or turn some data around or truncate the file, and then you feed it into an image parser. And if it crashes, then you probably have some bug. And very often, if it crashes, it's some kind of memory access issue, memory corruption, and that means you probably have a security issue. And unfortunately, the state of our software is very bad. Usually, the common case is you take a random piece of software, you run a fuzzer on it, and you will find crashes just within seconds. We have some quite powerful tools to do fuzzing and to find bugs. I want to mention two. One is address sanitizer, which adds some additional bounds checking to your C programs. It's part of LLVM and GCC, so it's just a compiler flag. Because sometimes if you have an invalid memory access, your program will not always crash. Sometimes it will just read or write to some invalid memory, but still run. So you don't detect the bugs. And address sanitizer will take care of that and will always terminate your program if you have an invalid memory access. And then there's American Fuzzy Lob, which is a very powerful fuzzing tool. It adds some compile time instrumentation and can then detect code paths. And it will do fuzzing, and if it has a fuzzing sample which is exposes a lot of code, it will use that for further fuzzing. This is very powerful, and it found already bugs in a lot of important software packages. Especially, for example, one of the shell shock variants was found with this tool. So yeah, these tools are out there, and you should use them to find bugs in software. And I personally started the fuzzing project, which is like, mainly it's a web page. It's just some kind of loose coordination of which software already was fuzzed by someone and where are open bugs that are not fixed yet and where are no developers available to fix anything. There's a tutorial because I really want to tell people if you have some basic understanding of Linux and programming, this is not hard. This is something... it's easy. You can do it if you're a software developer, and you should do it. Yeah. And my personal goal is at least the easy to find bugs should be wiped out, and this should really be possible. Yeah. So if you're a software developer, use fuzzing as a tool to develop and to find bugs. If you want to improve the security of free software, also use these tools. You can meet me after the lightning talks near the Gentoo table, and if people are interested, I can do a small workshop and show people how to do this. Yeah, that's basically it. And if you're interested in this and want to invite me to have a longer talk or some workshop somewhere, talk to me. Maybe we can handle something out. Thanks.
Yeah, thank you very much. Now, let me quickly deal with my drag and drop fail here. So this belongs to here. So, all right, go ahead.
Yeah, I'll test first. It works, okay. Hi to everyone. My name is František Algor Aflbeck, and I am one of the co-founders of Food Hacking Base project. Today, I would like to make a small overview of our activities, especially in the last year, and the plans for the future. So, page number 1. Who we are? We are people from all around the world who are interested in food, drink, and biohacking. You can also think about experimenting, coming together, having a beer, and doing also things which are a bit more specialized. We like open source, we like consensus, collaboration within different hackerspaces and hacker movement around the world. In our case, we really like to stay within the hacker movement and not to split, at least so far. At the moment, we are developing in the direction of being more like an umbrella for people and organizations who would like to join and work on the projects, collaborate. And yeah, staying in the hacker movement, very important. Now, what did we accomplish in 2014? At the beginning of the year, after 30 C3, we did a hacker tour around Europe, which we really enjoyed, around 40 hackerspaces, both in the West and in the South and the East. We can name Teching, Chaosquest, we have been in Brno, Novi Sad, many places. We promoted workshops, we have promoted different social dinings, you know, things like that, getting the community together. And another thing which we did, for example, we strengthened our web page presence. So we have now IRC channel, nice wiki pages, trying to build a forum. That's actually for the next year. Definitely experiment incubator. The ones who didn't try, special project which we are trying to develop in the long term, where you can use nice control environment for fermentations. Very interesting. Now, next year projects. We will prepare for CCC camp, running and improving our crowdsourcing campaigns, which we did several of them. We are generally successful, but definitely things has to be better. We want to push more for the biotech and more, I would say, really specialized hacking, food hacking. You can imagine cultivating, pure strains, using them later on, combining for different kind of polycultures. There are many things. Long talk. Now, of course, preparation for 32 C3s. We want to be permanently active more and more, not just on the congresses and camps. If you want to learn more about that, come downstairs, Hall H, and the corridor next to. You can talk to us. You can taste what we are doing. You can join our workshops. Food tasting, we are basically open source, open platform, which is funded by the people. If they want it, it will be there. Now, first food hacking base will be basically built this year in the island where I now live with my girlfriend, Jeju. We have a small fermentation facility. We hope to have there also a small biolab and hackerspace with hacker residency. So in the spring, we will be basically running for that small crowdsourcing campaign to support that. That's one of the kind of examples what we do and building really something in reality, because so far we are based all around the world. In this case, basically, we have small facility where we can really put the things into the practice in a more easy way. So this was the introduction. Thank you very much for giving me the opportunity to present. And I hope to see you around the Congress and downstairs. When you have time, pop in, let's talk, send me an email. Okay? Thank you very much. Yep.
Next talk will be up in just like 2 seconds or something. So this one goes over here and then go ahead.
Okay. Hi, my name is Georg Stebner. This talk will be in German because the platform I speak about is in German currently only. So, ja, wer von euch
ist hier auf dem Kongress, um andere Leute zu treffen und mit dem was zu machen? Mal Hände hoch. Ja. Dafür ist der Kongress da, um Leute zu treffen, mit denen zu kommunizieren und sich nicht nur Talks anzuhören, sondern auch wirklich was zu machen. Und das möchte ich hier mit dieser Plattform auch voranbringen. Helpdesk.net ist eine Plattform, bei der es um Teilen, um Vernetzen und eben um Helfen geht. Ich merke gerade, wir sind hier bei der letzten Folie angefangen. Das ist nicht so gut. Ja, das ist die erste Folie. Jetzt habt ihr alle schon mal gesehen. Wunderbar.
Die nächste ist nach rechts.
Ja. So, ich möchte mit der Plattform Leute dazu bringen, aus der Komfortzone rauszukommen und etwas zu tun. Mit Crowdfunding ist es möglich geworden, Geld zu bekommen für Projekte, um irgendetwas zu realisieren. Helpdesk.net geht es nicht um Geld, sondern es geht darum, wirklich anzupacken, etwas zu machen. Was bedeutet das? Wie genau sieht das aus? Es ist eine Plattform, wo jeder ein Projekt reinstellen kann. Er kann sagen, worum es dabei geht. Und es sind Aufgaben. Auf der rechten Seite seht ihr Aufgaben. Es sind Aufgaben gelistet, die man übernehmen kann. Man kann auf den Button klicken und kann sagen, okay, diese Aufgabe übernehme ich, da mache ich mit. So ein Projekt besteht aus einem Ziel, einem Ort, einem Zeitpunkt und eben die Aufgaben, die jeder dann übernehmen kann. Aber eigentlich ist das nicht das Wichtigste, wenn es um solche Projekte geht, sondern das Wichtigste sind die Menschen. Genauso wie hier, einfach Leute zu treffen, mit Gleichgesinnten etwas zu machen und etwas zusammen zu bewegen. Und um das abzubilden, ist es bei Helpdesk.net möglich, anderen zu folgen. Was bedeutet das? Wenn ich jemanden folge, bekomme ich mit, wenn der ein neues Projekt anlegt. Ich bekomme aber auch mit, welche Aufgaben er in einem anderen Projekt übernimmt. Und somit wird es viel einfacher, zusammen mit Freunden etwas zu machen. Oder mit Leuten, die man irgendwie cool findet oder sowas. Man sieht halt, was die Leute machen und kann das eben zusammen mit dem planen oder sich auch eben dann beteiligen. Und das bringt, denke ich, eine kleinere Hemmschwelle rein, weil man schon weiß, wer ist dort und was machen die Leute. Und ich weiß selber auch genau, was ich zu tun habe. Und es ist halt mittlerweile einfach so komplex, egal was wir machen, man kann nichts mehr alleine machen. Man braucht immer mehr Leute, um wirklich etwas zu realisieren. Also Zusammenarbeit ist wichtig. Und wo man das schon sieht, ein ähnliches Konzept ist GitHub. Bei GitHub geht es eigentlich nicht um Code, sondern es geht um die Leute. Zu sehen, was die machen. Es ist sehr einfach, Code zu ändern, sich selber einzubringen, selber was zu machen. Und Helpdesk.net ist so ein bisschen GitHub für die wahre Welt. Nochmal zusammengefasst, wofür ist Helpdesk.net? Ja, um zu helfen, um das zu teilen. Man kann es über Facebook, Twitter und so weiter, kann man das Projekt einfach teilen und sich zu vernetzen. Und es beantwortet halt die Frage, wer macht was, wann, wo. Und ich hoffe damit ein bisschen so diese Google Docs, die überall rum sind, für jedes Projekt irgendwo sind und man bekommt gar nicht mit, wenn man nicht weiß, da gibt es ein weiteres Google Doc, da gucke ich rein, wer hat sich da angemeldet für was, um das ein bisschen breiter zu machen, sodass jeder irgendwie weiß, okay, da sind Leute, die machen was und mit dem würde ich gerne etwas machen. Ihr könnt mich unterstützen, wenn ihr Interesse habt, an diesem Projekt mitmachen. Es ist mit Meteor gecodet und wer Lust hat, meldet sich einfach bei mir. Dankeschön.
Vielen Dank.
Macht was.
Yeah, please leave the clicker on the desk. Next talk, please. You can start.
Hi, my name is Sri Harsha. I'm going to talk about how to do two-factor decryption of your Luke's encrypted block devices. So a little about myself. I use full disk encryption on almost all of my devices. It used to be for fun earlier, but nowadays it's more like a necessity. And I hope it's the same with all of you guys. And one thing I'm more paranoid about is that when I type my passwords, anybody can see it, or they can interpret from my typing the same passwords for most of the machines, because I really have to be careful not to forget the passwords for the full disk encryption. I really want to use a two-factor decryption when I try to decrypt these Luke's devices. So I try to look around and to find how I can do this. One way is to use a USB media as a USB stick to hold a key file and then encrypt. And this media should support PIN style decryption to enable access to the file. Or I can also similarly use a PGP smart card and have the same type of decryption. But these two seem to be a bit difficult if I have to drive this process through the init RAM first when I try to boot the system. So what I found is that I can use something called a YubiKey. So this looks like this. It's a USB device. It connects like a keyboard. What it does is it generates one-time passwords. It can have RSA, and it can also, sorry, there's a mistake. It can hold an AES key, and it can do challenge response on this AES key. So, and this project is like, in this project, we ask for the user for a password. So this is the first factor, and then we derive a key, and now we read a encrypted challenge from the Luke's header. And now we decrypt this challenge with a simple XOR, and we challenge the YubiKey with this challenge, and we get the response, and this response unlocks your Luke's partition. So if you're doing it for the first time, the flow takes towards the right part, it generates a new challenge, challenges the YubiKey, gets the response, adds the response as a key to unlock your Luke's, and then encrypts the challenge, stores the challenge in the Luke's header, and it stores the challenge in the Luke's header. So a bit of dirty things which we do here are that this is due to the reason of space limitation in the Luke's header. We only have space where we can tinker around in these one of these key slots, and this project assumes that you won't use key slots 6 and 7. That's like we give you options to use 6 other key slots. So in the last slot is where we store the encrypted challenge, and the slot before key slot 6 is where we store the key which is actually corresponds to the response you receive from the YubiKey. And as always, you should also have a backup passphrase, which we'll probably have in the first 0 to 5 key slots. And as always, if you want to use this project, you should always back up your Luke's header before trying it. Yeah. So this is actually not started by me. I was just looking around in the internet, and I found the first one, but that didn't have the two-factor authentication I wanted to have. So I extended the one in the second one, and it hasn't meshed yet. I have to contact the author to take a pull request. And the third, so the first two currently do not support they don't have much documentation of how to do this in initram FS style boot up. And the third one has that, but it doesn't have the two-factor authentication. Yeah. So these are the things which have to be combined to get a good two-factor decryption of your Luke's when you boot up your computer. Yeah. Thank you.
Thank you very much. So the next talk, please. Sensing proximity. There you are. Okay.
So, hi guys. I'm Sam. I'm here with Sid and Patrick.
Please get behind the mic so people hear you.
And our professor sent us here to do
a weird experiment. This experiment is sensing proximity. So what does that mean anyway? You have phones, you have smartphones, you have Androids, you have iPhones, you have Yola phones, etc. And then there is Bluetooth on these phones. The newer phones have Bluetooth 4.0. Bluetooth 4.0 supports Bluetooth Low Energy. And Bluetooth Low Energy, you can do many cool things. You can make tiny beacons that send out a signal every 1 second. This signal can be picked up by these phones in the background using low energy, right? And so what can you do with this? You could make a map. And that's what we are trying to do. We're trying to make a map. We're trying to make different maps. A social graph, so a map of relationships between people. So if you're with a group of friends here, you would appear as a cluster on this map. And it would be interesting to see also if this cluster changes in time. So if, I don't know, you meet new friends here, we would theoretically be able to see that you're moving from one cluster to another. There are many issues here, but I'll go into them later. So the beacon is picked up by 2 phones. We get that sent to the server, and we have a kind of information on the location of this beacon, of the phones, because we know the location of the beacon, right? So we're trying to do this with 2 apps. They are really being overwhelmed by downloads at the moment. We did not do any advertisement, so it's really crashing our server at the moment. But it's good, it's a good thing. And we are really learning a lot here. So when you download it now, you will be uploading the proximity data of beacons around you. So any beacons here in this box here, or statically installed in the room, will be picked up by this app and will be sent to a server and then collected. This will also, the Android app will also allow you to share some other data. This is interesting because, like I said before, these clusters that form, your friends, your new friends, they have different properties. They have accelerometer data, they have battery data, temperature. And so you would see in a very noisy room, maybe like this one, when you all talk, you would see like a very noisy cluster, and you could assign a color to that noise. Say red is high noise and green is low noise. And these beacons were manufactured by us with a 3D printer and a very simple Bluetooth module, the HM10, that basically you just configure it with AT commands, and then it just works. It just sends out the signal. But it was a real pain. If you want to manufacture 120 beacons, you gotta know what you're getting into. So this is an example of how the graph will look like. And maybe Sid and Patrick, who are sitting there, are showing you right now the real-time graph of around 100 people in this conference right now. If you go up closer later, you'll see it in detail. So issues, again, scalability. We were overwhelmed by the people downloading this app, and we had like 30 transactions per second on our tiny little MySQL server. So if you can help, please help. We need Python skills and MySQL skills. The Bluetooth signal is also an interesting thing. So when a lot of people are sitting in a room like this, the signal propagation changes a lot so that we can see different locations of different phones, even though they're at the same place. Exactly. So we are having a discussion later on where we want to talk about this in more detail. Because we are collecting a lot of data and we don't want to be a datenkrake, we want your opinions on how to do this in a privacy-preserving manner. We want to know what feels not right for you and what is the way to go with this. We've thought of also setting up a mesh net with the app to transmit the data, but that seems to be a bit buggy in the moment. So please come to our discussion, and we will be giving out free beacons as well. So if you want, I could just throw this into the audience. Please be prepared. Don't die, sorry. Okay, there you go.
Okay, thank you very much. Okay, the next speaker, please. She's coming from there, okay. The
All
clicker is on the desk
speakers,
there.
this is a service announcement to all speakers. Please be reminded to stay in the front row before the beginning of your talk. It would be nice so that we can have continuous talks here. Thank you.
Go ahead.
Okay, hi, I'm Emily Hammis, and I'm a scientific diver, which is kind of a different side of, I guess, hacking than a lot of you guys are in. One of the things, I switch. One of the problems with scientific diving that you run into a lot is there's a lot of sensor systems that are easy to create and hack and so on, but they're not really designed to go underwater, primarily because you have your electronics and you have your sensor. So in this case, those are my electronics. And the sensor has to penetrate the case in order to be in contact with the water. But you can't have your electronics get wet. And you want to leave it down there for a week or 2 weeks or a month. So it needs to be very watertight. And so you also don't want to have a system that's permanently stuck to your encapsulation method. So you need to have a gasket system so you can remove it. And in this case, the sensor penetrates with a gasket, which is the green arrow. So how does this gasket allow the device to be watertight? Basically, each one of these screws has a force that goes down on this big plastic sheet, and that puts force on the gasket, which translates into a squishing into the sensor itself. And that pressure causes a tight seal on the sensor system, which then allows the device to be watertight for periods of weeks or more. And so why do I have so many screws? That's another question that I keep having people ask me. Well, basically, I have 2 gaskets, and they have different surface areas. And so because each one has a different surface area, you can't have the same screw put force on each gasket, because it'll put way too much force on the red gasket and not enough force on the blue gasket to get a seal. And in fact, you can crack the plastic plate on the top. So you have different sets of screws for each case. And in this case, those are the 4 screws, or the red screws correspond to the red gasket, and the blue screws correspond to the blue gasket. And that's really all I have.
Okay, thank you very much. We still would have time for some questions if you would like. So any scuba divers here having questions? Or non-scuba divers?
So in that case, that measures just temperature, but we plan on measuring.
Could you please get behind the mic and repeat the question?
Sorry, what is it measuring? And actually, in that case, it's measuring just temperature, because temperature sensors are cheap, and if it screws up, we didn't want to waste a lot of money developing like a pH meter, for example, because those are very expensive. It was more because I just basically did my scientific diving license. This was part of the training, because we have to test something that we create. And so we chose to do a temperature sensor because we were actually diving in a geothermal vent, which is kind of like Yellowstone National Park, only under the water near Stromboli, which is north of Sicily, or the north part of Sicily. And so temperature is actually important, especially because that volcano is erupting right now.
Another question? That's not the case. Then thank you very much for your talk. So next speaker, please. Do you recognize your slide? All right, there he comes. From the back row.
Hello, everybody. My name is Michael Schommer. I'm from Stuttgart.
Next slide, please.
The clicker should be on the desk there.
Der da, meinst du?
Press
Okay.
the right button to advance.
Wunderbar.
Yeah. All right.
Ich will ganz kurz erzählen, was ich habe zusammen mit ein paar Freunden in diesem Jahr 2 Konferenzen veranstaltet, das Prism Camp 1 und 2. Und es waren Barcamps zum Thema Überwachungsskandal. Das heißt, ein Barcamp ist eine selbstorganisierte Konferenz. Jeder kann da kommen und mitmachen und seine eigenen Themen präsentieren und seine eigenen Fragen stellen. Das werden wir nächstes Jahr weitermachen. Am 10. bis 14. Juni in Stuttgart wird es die No-Spy-Konferenz geben. 3. Konferenz zum Thema kommen, mitmachen, anschauen, diskutieren, Sachen ändern. Der Titel wird sein Politik, Gesellschaft, Technik, Hacken, um gegen die Überwachung der Geheimdienste vorzugehen, sich selbst engagieren und Dinge ändern. So, unabhängig von, oder nicht unabhängig, sondern als Ergebnis der ersten beiden Prism Camps haben sich Arbeitsgruppen gebildet, die sogenannten Prism Labs. Und die Prism Labs machen Dinge, wie zum Beispiel Unterrichtsmaterialien für Lehrer oder Flyer, Sticker, Graffiti, Stencils mit unseren Botschaften. Sowas wie dieser Aufkleber, nein, die NSA ist Ihnen näher als dieser Aufkleber beispielsweise. Oder die NSA filmt dich... Danke, die NSA ist Ihnen näher als dieser Aufkleber. Oder die NSA filmt dich beim Porno gucken. Ich habe davon ein paar machen lassen, die sind leider noch nicht da. Vielleicht kommen sie bis Dienstag. Genau. Und, oder was wir auch machen, sind Besuche bei Politikern. Ich war um die Politiker zu sensibilisieren, ich war am Montag bei einer CDU-Bundestagsabgeordneten in der Bürgersprechstunde und habe mich immer noch nicht von dem Besuch erholt. Das geht, danke. Ich opfere mich da wirklich auf. Das ist echt ein hartes Brot, diese Besuche bei Politikern. Aber naja, vielleicht bringt es ja wirklich was. Zeit ist auch gleich rum. Ich halte übermorgen, also an Day 4 ist es, glaube ich, ne? Day 4, um 10:30 Uhr, also vorm Aufstehen, in Hall A. Einen etwas besser organisierten Vortrag, wo ich nochmal genau zeige, was machen wir bei den Prism Camps, beziehungsweise zukünftig heißt es dann No-Spy-Konferenz und was machen wir in den Prism Labs für Dinge. Und dann habe ich auch Aufkleber dabei, vielleicht, bestimmt. Okay, letzte Sekunden. Also wer übermorgen noch da ist, ja, Zettel. Day 4, 10:30 Uhr, vorm Aufstehen, Hall A, die Langversion von dem, was ich gerade erzählt habe. Und wer keine Zeit da hat, aber zufällig im Juni in Stuttgart ist, 10. bis 14.06. Stuttgart, 3. No-Spy-Konferenz. Die wird 20 € Eintritt kosten, wie bei so einem Barcamp inzwischen üblich, mit Verpflegung. Und ja, ihr seid alle willkommen, herzlich eingeladen. Und die Zeit ist rum. Vielen Dank für eure Aufmerksamkeit.
Ja, vielen Dank.
Super.
So then we'll go on with the next talk. P2P value, that's you. All right.
Hi, good morning, afternoon. So P2P value. P2P value is a project made up of these partners you can see here, and it's funded by the EU. And what it's trying to do is to investigate the value that's generated by commons-based peer production, which is a big term, but basically means production of things like Linux, Wikipedia, OpenStreetMap as being the kind of biggest cases, and also the kind of investigation and building of a software platform which would facilitate the kind of relationships that make up those organizations and their work methods. So we've kind of defined commons-based peer production as it's collaborative production, it's got a peer-to-peer relationship, it uses common resources, and it's open access. And the way we're doing this is basically through this diagram. So, excuse me, research, which feeds into the analysis and design, which goes into the co-creation, which is tested, and the feedback is gained, and this is actually by people, by real communities, not by researchers or whatever. And then that goes again into the research, and the whole process goes on. So the project was launched officially in Barcelona in the 22nd of January. 150 people were there. It was involving all of the kind of communities we're looking at, so researchers, hackers, civic society, policy-making actors, etc. And one of the first parts of the project was an investigation into the kind of existing groups of commons-based peer production. But when we tried to do that, we couldn't actually find any kind of registry or any place where we could actually find all of these groups. So we had to build one. So we built this directory, which now features over 350 commons-based peer production groups, and as far as we know is the biggest directory anywhere. So you can visit that, you can explore it, you can download all of the information there. And if you are in a group that is involved in commons-based peer production, please add yourself to that database. As I say, anybody can go in there, the address is there. It's a very straightforward, simple interface. You just log in and then put in all your data and information. And we'll actually be building on this directory this year. We'll be hosting 2 kind of data jams in Barcelona to use better this directory. Another thing that we're doing, we're also hosting like a public event calendar. So if any common-based peer production groups, because again, we couldn't find any kind of central calendar of activities of groups that were involved or were doing. So we're hosting that ourselves on the website, p2pvalue.eu. One of the other things we've discovered is that the kind of communication around open source about commons-based peer production is often very, very bad. So we've done a set of posters, which we hope are user-friendly, which are explaining, for example, this is one day in the life of collaborative communities. These are crazy things you can do. And here's like a history of commons-based peer production communities. I've got a few here. I'm not going to throw them into the crowd, but if you want some, you can come and see me and I can give you some. They will be uploaded onto Wikimedia. They will be downloadable and they will be editable also. So one of the things apart from doing the research, we've been working on the actual platform itself, and we were using Google Wave, which became Apache Wave, and we've built an API for Wave, which is kind of fairly unique. It's a decentralized alternative. It's compatible with the Google Real-Time Collaborative API, and we see that as an opportunity for building an ecosystem of other CBP apps. At the moment, it's JavaScript, and soon it'll be for Android. It's on GitHub if you want to check it out. And the most important thing is that we're holding a workshop in London, March the 16th and 17th, which is basically to gather FLOSS groups that are working on distributed platforms. There'll be lightning talks, there'll be show and tell, there'll be tutorials, there'll be an unconference, and there will be scholarships available. So if you are interested in coming, please look at that address, P2P Value, Second FLOSS P2P Workshop. Thank you.
Thank you very much. Then we'll have our last talk for this session. So please start.
Hello. So we've been hearing a lot about information that was made more available, more accessible via journalism through news organizations. And so I want to tell you about how you can join the news nerds, bring your skills to journalism, how you can apply those skills in this field. So first, hi, I'm Erica. I am based in Philadelphia, which is known for things like Rocky and the Liberty Bell, but we also have a really active open source community. I got involved through being involved with Drupal. We have a very active civic and open data community, and that brought me to Night Mozilla Open News, which is where I work now. We exist to support the journalism code community. That is the community of news nerds. We support this community in a lot of various ways, and one of the first questions that people often ask is, what is journalism code? So journalism code is some of the code that actually drives a lot of what we access on the web. Django is a web framework that was developed in a small news organization in the middle of nowhere, USA. Backbone.js came out of a project called Document Cloud that news organizations use to deal with PDFs and make that information more accessible. And these are technologies that are used far beyond what is happening in journalism, but were developed within news organizations. Journalism code also helps you understand the world. In addition to things like the NSA revelations, there's also projects like this, which came out of a hack day that we organized in June, which compared maps of disputed territories around the world. So who creates this code? Kind of fun name for that community are news nerds. So it's kind of the combination of news, journalism, not exactly nerd candy, but it comes together to be a field of people who have an interest in journalism. They work in news organizations. They do work supporting news organizations, but they bring development skills, technical skills, programming skills to that work. So they solve problems through code. These are a few particular examples. Tabula is a tool that solves the problem of extracting tabular data from PDFs. The grid is an example of analyzing metrics data to understand how people use interactives on a website. And that's a picture of a little girl playing with an Arduino to figure out when the cicadas were going to come out in and around New York City last year. So news nerds also work on really challenging, important issues. Secure Drop is a really important project that's happening to help sources communicate with journalists more securely. And there's also a lot of other topics and projects, both with international relevance, but also things going on in your local community. So you can become a news nerd as well. How? So getting involved in your local area is a great way to get started. This is a map of local journalism hack-related events that Open News has sponsored around the world. You can definitely see a concentration in a few areas, but we're very interested in supporting events that are happening related to this space all over the world. There's organizations like Hacks Hackers, like the Open Knowledge Foundation, data-driven journalism groups that are also doing work in this area and might be working in your town. You can also learn more on our website source.opennews.org. There are learning guides, there are code repos of journalism-related projects, and there's even a job listing site if you're interested in working full-time in the field. You can also find journalism-related projects to work on. This site lists a lot of GitHub repos that are projects that are being developed in and around news organizations. And so if you just want to dive right into the code, you can do that as well. And you can also become a Night Mozilla Fellow, which is a program that we have where we embed developers, designers, people who like solving problems through code with news organizations for 10 months for a paid fellowship. And a couple of our former fellows are actually here at the Congress, and I'd be very happy to talk with you about this opportunity as well. So please join the news nerds. Very happy to talk more. There's some contact information there. So thanks for your time.
Thank you very much. So that concludes today's lightning talk session, which was a very interesting session from my point of view. And not only did we have a large diversity of topics, we also had every speaker on time, so we didn't even have to buzz anyone out, which is very great. So please give a big hand to all of the talkers. Also, thanks to the awesome translation team, which is a very hard job, especially in the lightning talk sessions due to such many different topics, for translating all these talks into German. And then let me quickly announce the sessions tomorrow and the day after that. So at the same time, in the same room, there will be the lightning talk sessions 2 and 3, which are probably full by now. So we have the same amount of talks tomorrow and the day after that. See you.